NIDPR Guwahati. So we have a regional center in Guwahati. So I am delivering the lecture from Guwahati only for regional center of NIDPR Hyderabad. So friends, I will be sharing. I think that the instructions will be remain same as we followed the previous sessions. Okay, try to keep it mute. If you have any specific query question, you use the chat box. Okay, and this is not a big session. In fact, the syllabus of this particular block is somewhat less than compared to other sessions. So keep in mind that we are within a stipulated time we'll finish it, right? If you have any questions, we can interact. You can use the chat box as well. Friends, can you see the screen?
Yes.
Okay. But some of they want to join. In between again disturbance is coming to join new people. I think we will not allow, it seems, right? Yes, friends, we'll start our session. I think this is the GARD 401 Geographical Information System, and Dr. Prasad might have discussed all the concepts of the GIS and data and the necessary components of the GIS, right? The part of that particular GARD 401, we have a block number 3 there, that is data models and data structures. So this particular block will be discussed. As I said, I will not take much time, right? As the syllabus is, particularly this block syllabus is compared to less than other units, blocks. So in this particular block, we have 4 units. The first unit is spatial data models. The unit 2 is non-spatial data models. The unit 3 is spatial digital formats. Unit 4 describes about spatial data creation. So under this particular block, we have 4 units. These are the 4 units under block 3, data models and data structures. Keep in mind that data means the spatial data models and spatial data structures. So come to the unit number 1, spatial data models. So friends, you are all aware, as Dr. Prasad might have discussed, GIS is a computerized spatial information system. It's a spatial information system. So it will give the information. The GIS always give the information system about the spatial data only. I think you're all aware what is spatial data, what is non-spatial data or attribute data. It might have discussed by Dr. Prasad. And the GI, it requires spatial and attribute data for furnishing much needed spatial information to the decision makers and executives in map form. So the both were used. It's always, you keep in mind that it's a computerized spatial information system. Geographic information system is computerized spatial information system. The system requires spatial and attribute data. Though in data models, basically we see both. What is the spatial data models we have? First of all, we should know what is spatial data and what are the spatial data models we have will be discussed, and also will be discussed what are the attribute data we have and what are the attribute models, data models we have in this particular unit. And the spatial data is about location and relationship of various geographical features which are present on the surface of the earth. It's very simple. Spatial data means it's about location. It is location in terms of latitude and longitude, that the coordinates. Coordinates of the earth features are geographical features. For example, the water body, road, settlement, river, forest, cropland, all these called geographical features. The geographical features means which we can see with our naked eye or existing features on the surface of the earth. These are all called geographical features or spatial features. So the spatial data means the data which we are seeing on the earth, all this geographical data will have latitude, longitude, coordinates or existence on the earth. So this we call spatial data, the data which have latitude and longitude value. And secondly, non-spatial data we'll discuss in separate unit, but these two are very much related. Spatial and attribute data are so much related to each other to form geographic information. I think that the full form of GIS might have discussed by Dr. Prasad, Geographic Information System. Geography means spatial data, right? The data which is located on the Earth's surface. The non-spatial data or attribute data means information describe about that particular data. Suppose we have a tree on the surface. The tree is spatial data. When you talk about tree, the name of the tree, which type of wood it give, which type of leaf it will give, right? Which type of fruit it will give, flower it will give, all is called attributes. Okay, so in GIS, when you add this attribute, it become geographic information system. Geographic information. Geography and then information become geographic information. In GIS, these two data are very much important. Geographic data as well as non-geographic, that is attribute data. So in this unit, particularly after the spatial data, we have the topology. Topology is very much essential. Topology denotes spatial relationships between geographic entities based on location. Based on location. Geographic entity means what? Just a minute. Somebody wants to join. Sorry. Yeah. I think we'll discuss a little later. It seems you cannot answer now. So I'll go ahead. Hope you're all hearing. Can anyone respond?
Yes, sir.
Very good. Very good. Very good. The topology denotes spatial relationship between geographic entities based on location. So topological data structure will be the basic elements of topological data structures are arc, node, vertices, and then polygon. So these geographic entities will be described as point, line, polygon. Basically, to prepare a map, geographic entities will be point, line, and then polygon. When you talk about topological data structure, right? The basic elements of this particular topological data structures are arc. Arc means a line segment connecting two nodes. A line segment connecting two nodes. Node means what? It's a meeting point or location of two endpoints of an arc called node. So, and then vertices, which is very much essential in our vector format, which are the series of points which defines the shape of an arc. Vertices means is a series of points which defines the shape of an arc called vertices. And then we have polygon. Polygon is a closed arc, which will basically give the area concept, and the origin and the destination of an arc will be the same point. Where it starts, it has to be and from to the starting point only. Two adjacent polygons will share a common arc. So these are topology. Why this topology will be used? Topology basically it will remove your errors, right? It will remove different errors. When you extract or generate your data in GIS, we used to create a topology. We build the topology. When you establish this topology, it will remove errors like overshoot, undershoot, as there in a gap or overlapping, right? These and all will be corrected using this topology. Once we build this topology, we correct our geographic data using different methods in topology. So different types of topology can be seen here. Based on its nature of topology. The one is connectivity. The connectivity of one geographical entity with another entity or intersection of one entity by another entity. It shows connect. You can see the picture towards the right side. First one is connectivity. Suppose basically if it is the example road networking, when you digitize a road networking, there's a main road is there. There are number of adjacent roads or joining roads were there. Once you digitize it, there may be gap, right? You are not connected properly from that adjacent road to the main road, right? So using this topology, you can correct it, the connectivity. And second one is adjacency, is which entity is adjacent to a given entity or contiguous to entities. And then containment we have. The containment indicates which entity is contained in another bigger entity. For example, it's an island within a big lake. You can see towards right side, there's a picture of containment within that island and then big lake. You can see within the feature, which will be shown as a polygon feature. And we have proximity topology. It shows that entity is close to another entity. Proximity is close to another entity. And then we have relative position. Relative position denotes that relative location of spatial entity to another entity. Friends, basically, with the previous experience, the question may come that what is spatial data, what is non-spatial data, and then topology. Or they may ask 2 marks question or maximum 5 mark question. What is the topology? What are the different types of topology we have? So you have to denote all these 5 types. That is connectivity, adjacency, containment, proximity, and then relative position of the topology. If you can draw these pictures along with your text of these 5 types of topology, that will be good. Okay, keep in mind that whenever you say something, if a graphical representation is there, kindly use that graphics also always along with your text so that you will get maximum marks in the exams as well. Topology, what is the topology you have to describe? And topological data structure you have to describe, okay? And then types of topology. When you talk about topological data structure, there are 4 types we have. One is arc, another one is node, another one is vertices, and then polygon. Keep in mind that these are 4 topological data structures we have. And then you have to define what is topology, then structures, and then types of topology. These 2 are very much important. Always it comes, what is the topology or types of topology? Keep in mind that this is important. Noted this. And then we have spatial entities. What is spatial entity? Basically entities that are distributed on the surface of the earth are broadly categorized as point, line, and polygon. These 3 are called spatial entities. Just a minute, somebody wants to join. I'm sorry, in between people are joining. Yeah. So these spatial entities, what we do is, these entities are distributed on the surface of the earth. As I said, these are all geographical features. These are all geographical features called spatial entities, but we will use some symbols. That is, we will use some entities to enter this data into GIS environment to convert into vector format. All this geographical data will be entered using point, line, and polygon. These 3 are called main spatial entities. An entity assumes its name based on its nature. As I said, if the spatial entity has only location, that is point. For example, temple, well, ATM, right? XYZ. So these are all will have single point. This is called point feature. It will have single location, single X and single Y. The only one latitude, one longitude, right? Which we called point feature. This particular point feature will have single entity. And then when the entity is a linear segment, which may be connecting one place with another place. One place with another place, like road, river, stream, telephone line, electrical line, railways, etc., called linear segment, which will be entered into GIS environment, or spatial entity will be used for linear segment is line entity. It will be line. It will be line. That one is point entity, which will have the single coordinates, which a single latitude and longitude value. And linear segment will have line entity, which will have different number of latitudes and longitudes, which will be shown as linear segment called line entity. This is second special entity. The first special entity is point, second one is line special entity. When the special entity occupies some area, as in the case of forest, water body, cultivable land, area under different soil, etc., are known as polygon feature, or maybe village boundary, maybe your ward boundary, maybe block boundary, maybe district boundary, right? These are all will have area concept. So these entities occupy some area. So this called polygon features. Polygon features are polygon entity. So we have three types of special entities, which is very much important, friends, in the GIS. We know the concepts, we know the data, but when you enter the data, different model of data we have, the vector and raster. Basically in GIS we work, this is a vector based software. We enter all our geographical features will be using these three special entities, that is point, line, and polygon. As I said, where we will use point, where we will use polygon, where we use line. As I said, point will have only single coordinates, that is single latitude, longitude. Line will have linear segment, the number of lat long value will give, but the entity will be in linear segment. Whereas polygon will be entity occupies some area concept like boundaries, basically. In the case of tank, water body, cultivable land, forest, right? And administrative boundaries, all will comes under polygon feature. So these are the three entities, friends. This is also important. Almost every year it comes, this is a question as a special entities. You have to denote and also you have to draw a picture. Keep in mind, friends, not on text will not help, right? Since you are doing the geographic GIS course, along with the text, you must ensure that you are drawing something, right? If you describe about the point special entity, you have to show as a point with example. If you are describing line, linear segment, or line entity, so you have to draw along with your text. What is the line segment? You have to describe and you kindly show as a one feature in the drawing. That may be road or river or XYZ. And when you draw an area, yes, you also show, you describe about area. What is the area? How it makes, right? And also draw the polygon feature, maybe boundary, right? Some boundary with some area, so that you will get maximum marks. But this is also very important unit, the special entities. Thus, the real world geographical entities are grouped under three categories. The entire real world geographical entities are grouped under three categories, as I said, point, line, polygon. So this classification of spatial entities, friends, given, the two types of classification given. The first one is qualitative, then the second one is quantitative. For example, if you take the point entity, the qualitative point entity will be shown as like well, temple, and borewell, ATM, PTO, or some police station, right? So if come to the quantitative entity, the point entity can be shown as a quantitative as well, particularly triangulated station, spot height, benchmark, etc., which will have the quantitative parameters in that point entity. Similarly, line, in case of line, you know the quality is like road, railway, overline, stream, river, etc. In case of quantitative entity for the line is contour. You might have read already what is contour. Contour is an imaginary line with equal elevation, with same elevation. So it will give the elevation in number. It will give the quantitative description. That's why it's shown, the particular entity shown as a quantitative entity. The contour itself will give the quantity. It shows only elevation. Purpose of the contour is to show the elevation of the same area. So it is a quantitative linear entity, the line for contour. When you show as a line entity in road, railway, power line, stream, etc., it's a qualitative entity. It will show the road, right? It will show the railway line, where it exactly existed, the power line, etc. And the polygon, so the similar one, the polygon also, you see the quality, polygon where we use like administrative boundary or cropland, XYZ, water body, all these. If you come to the quantitative entity in polygon, particularly density of population, particular census information, when we display, in that case, we use density of population, sex ratio, percentage of cultivable land to total geographical area. These are all quantitative entities. Friends, you should know what is spatial entities and then classification of spatial entities. As I said, you have three types of entities: geographical entities or world geographical entities, spatial entities. Any word you can use, that is point, line, polygon. And when you classify it, there are two types of classification has to be made. One is qualitative, another one is quantitative. Somebody is asking to allow.
Sir, could you please hide that dialog box underneath?
Yeah. How it is, but for me it's not showing. Which one, sir? Okay. Yeah.
Sir,
Now
there was one.
Now can you see? Is it okay now?
Yes, sir. Better.
Yeah, please keep in mute. Yeah. Please keep in mute. Thank you. Thanks for correction. And friends, yes, we have to know special entity and then classification of entities. There are two types of classification of entities we have. One is qualitative, another one is quantitative. Keep in mind that qualitative and quantitative special entities we have. These two are already described. When we show the quantitative information as a special entity, that comes under quantitative. When we show the quality, it will come under qualitative special entity. Only few will be shown as a quantitative, whereas 80% will be shown as qualitative special entities only. Around 20 to 30% will be shown as quantitative entities. Particularly the census data, when you display, that will be quantitative entities. And then from spatial data models. Of course, our block or session starts with the data models, but always when we work in the GIS, you should keep in mind that we have spatial data. Data means what? Right? There are a number of data we have, but when we work in the GIS, basically we work with the both spatial and non-spatial. But first one is spatial data model. So what is spatial data models? What type of models we have? I think already it was discussed by Dr. Prasad Mehta in the first session, interaction. Basically, we have raster and vector, right? Spatial data model. And the data models has represent location, type, and relationships of a spatial entity. Just now it was thought what is spatial entity. Okay. So it's a data model has to represent location, type, and relationships of a spatial entity. Each and every model supports a set of spatial operations that other models may not handle effectively. So in GIS, two data models are used frequently to handle spatial data. As I said, one is vector. Of course, around 90% the spatial data model will be used in GIS, that is vector model only. And second one is the raster. Friends, you might have already known and read in the book, GIS itself is a vector-based analysis software. So we use maximum data models will be vector-based. So in GIS, two data models will be used, right? That handles, that is vector and raster data. So spatial data models, vector, what is a vector? What is a raster? You can see the vector format, the discrete representations of reality using coordinates, using latitude, longitudes. That vector representation will be made, that is XY is indicating as it denotes, you can see the vertices, that will be shown as a vector format, a discrete representations of reality using coordinates, right? As you know, the vector format is point, line, polygon. It will be used point, line, polygon, a discrete representations of reality. You can see the reality highway road has been shown in the picture towards right side, and the same has been drawn in vector, the same highway road being shown in raster format. When you show some geographical entities or features in vector format, this will use the latitude, longitude, friends. It will use latitude, longitude, basically point, line, polygon, or vector formats, and it will be used the coordinates in different vertices to form this point, line, polygon. Whereas raster formats, basically it use square cells. It use square cells to model the reality, whereas vector use point, line, polygon, and coordinates to do the reality. But the raster format, it is square cells, the pixels, columns and rows. You can see this is the raster format. I think which will take our digital photograph is raster format, satellite images which comes in raster format, right? If you keep on zooming your photograph in computer and laptop, you will finally get these pixels, these columns and rows, right? Which we call raster format, which will made up with the cells, square cells. The each pixel will have the value of DN value, that is the number will be there. And I think Dr. Kesharo sir might have discussed about what is the pixel in the remote sensing class, which satellite will also made up with these pixels, which will be shown in raster format. Excuse me.
Hello, sir. Good morning, sir. Sir, class. Sir, 12 बजे को meet होगी.
Yes, sir. So spatial data represented in space vector and raster. So the raster format basically shown in pixels, like our camera 10 megapixel, 20 megapixel. The picture also quality depends on that, and it will be stored in these pixels. Our photo will be stored in these pixels. If more pixels we have with the less size, then the quality will be high, which we called more number of pixels. 20 megapixel camera, 30 megapixel camera, 40 megapixel, right? If you use 20 megapixel, it doesn't mean that it will cover more area. It will give more quality because of this pixel size is less. Even our TV, computer screen, all these raster digital formats, which will be made up with the pixels, columns and rows. Friends, come to the advantages and disadvantages. So what is the advantage and disadvantages of raster data model, which will made up with the pixels, columns and rows? So advantage of this raster or data model is data analysis is easy and quick to perform, and ability to store continuous surface data and easy to process surface analysis. The uniform structure permits the user to perform various analysis such as query, reclass, overlay, etc., which is very much essential. When you do some analysis, like some models analysis, when you go for a hydrology model, you have to keep your all vector data, you have to convert into raster format to get some reclassification for overlaying to merge. So that has to be done. That is only feasible with the raster. And point, line, polygon features can be combined in the raster format. You can make it together, you can combine, you can make it join together. And lossy and lossless compression can be done for data storage. The cost of application software is cheaper, particularly when you compare with the vector-based data software and the raster data model software. If you compare, the raster-based one obviously is cheaper than the vector-based one. Then high spatial variability is easily represented. So these are the few advantages in raster. And also, if you want to give some weightages, friends, particularly if you see the point number 3, During the reclassification, we give some weightages to perform such analysis. As I said, hydrology model, particularly if you want to take hydrology model or watershed model, you have to reclass all your vector-based layers. Maybe land use, land cover, or soil, or drainage. All this has to be give weightage to construct different structures, engineering structures across the streams. In that case, the raster will help you a lot to give the weightages where we cannot give any weightages in vector format. Still, we use 90% vector, but if you want to do such analysis, the data, vector data will be converted into raster format to give the weightages and reclassification, reclass those weightages and values. Well, always wherever you have some advantage, always there will be some disadvantage. So here also in the raster model, so you have some disadvantages like data sets are larger in size compared to vector. Vector will occupy very less space, friends, but a raster data will occupy a lots of space. If you see the satellite images and all, it goes in the GBs. It will occupy GBs in the computer. And once you add into the computer, sometimes you get hang when you have the more raster data. So the data sets, particular raster data sets, are larger in size. And providing projection and transformation is tougher here compared to the vector. Topological representation cannot be done here. If you have any error, like I just said in the topological error, that cannot be done here. Like undershoot, overshoot, that and all only done for the vector file. Topology can be generated or it's generated for vector data only, not in raster. And cell size determines the objects that can be shown. Its cell size determines the object can be shown, not like vector. Based on your cell size, sometimes the clarity will go down if the cell size is big, right? The linear features are hard to represent, and so network analysis cannot be carried out in raster model. Let's keep in mind, network analysis we cannot do in the raster model, and stores only single attribute for a cell. In raster, you cannot add any attributes like vector. As I said, GIS deals with the vector and spatial and non-spatial data. But here you cannot store any attribute. You cannot add anything. Suppose there is a road. For the road, if you wish to add a name of the road, type, condition, XYZ, that you cannot add here raster. This road has to be digitized. It has to be converted into vector format to add all attributes. So it will have only single attribute, that is the cell size. The DN value or decimal number will be there. Each pixel, each cell will have their unique number. That will be shown as only attribute. Nothing else will be there as attribute here in the raster. We cannot store in any other attribute data for raster. As perimeter is many others, you cannot get any perimeter and shape always in the raster. Is not at all advantageable. If you want to get perimeter and shape, we always analyze and measure in the vector format only. So these are the disadvantages of raster data. These are advantages, and then these are the disadvantages of raster data. And advantage of vector data. Advantage of vector data. Data will be represented in its original form, since most of the hard copy maps, such as Survey of India maps, represent the data in vector form. It will be easy to show the data in vector format than in raster format. If you compare kindly switch off your camera, Dr. Sandeep Kumar Tripathi ji. Dr. Sandeep ji, kindly switch off your camera. It's disturbing to others. Okay, I think he will. Dr. Sandeep ji, please kindly switch off your camera. Well, so then its another advantage is a correct geographic location of the data is maintained. Its pinpoint location can be shown, as you can show, indicate the point line polygon, and the topological construction can be carried out easily, as I said, which is not possible in the raster, but here it is possible. It is feasible in the vector data only. as I said, the checking of adjacency, containment, analyzing the network, etc. If there is a gap between road to road or point to point, line to line, that can be, please keep in mute, please. So that can be rectified. Those errors can be rectified, like overlapping, adjacency, or overshoots, undershoots. All this can be carried out. The topological construction can be carried out in the vector format. You can check it here, and you can rectify those errors, which is not possible in the raster. Occupies less storage space, friends. If you compare with the raster, it will occupy very less storage. Hardly the entire project will be shown in hardly 500 MB in vector data. Hardly one project, the number of layers can be shown. So it occupies very less storage space, which will enable, and once you add the number of layers, also it will not got stuck as raster, because raster data will have, it occupies more space. In the vector, one layer can consist of more attribute information, which is very much essential. Hence, it occupies lesser memory space, because as I said, friends, the attribute information, like road is there, one road is there, you can give number of all the information as attribute, like name of the road, type of the road, condition of the road, in which year it was constructed, right? And then under which scheme it was constructed, and how much money has been spent, who is maintaining that road. All these attribute or description can be added to vector data, which is not possible to add to the raster data. And it is shown in one attribute information. In single row you can show. For one each layer, you can show as a single row all this information. So it occupies lesser memory, and it will give more information. Not only that, friends, the another point which I have not mentioned over here, the another major advantage of this vector data is the data can be updated. Data can be updated. Suppose the road was digitized or mapped the last year in 2019 June. Now it was in that particular village, the road was Kacha. But recently under PMJ's scheme, Prime Minister Construction scheme, the road was being constructed or converted into Pakka road. So how you do it? Can we change the map? No. The same data can be converted, can be updated with single click or single changing of your attribute. The data will be changed. So go to the attribute where you have the attribute column as a type of the road. It is Pakka, Kacha, Semi-Pakka or Pakka, Kacha. Instead of Kacha, you make it in the attribute just to change it as attribute as a Pakka. So the Pakka road color will come automatically in geographical feature, and then your attribute will be updated within a minute time. So this is another major advantage. You can update the data easily in vector data model compared to the raster. Raster, you cannot do anything. This is the major advantage. Data can be updated. And then projection and transformation can be done easily to the vector data. A projection and transformation, right? One projection to another, or datum can be changed very easily. It can be transferred very easily in vector model. Friends, this particular question, advantages and disadvantages of vector and raster model, very important. It will come 100%. I cannot say whether it will come 10 marks or 5 marks or 2 marks, but with my past experience, I say that this particular question will come. Different data models, that is what is vector, what is raster. Again, please try to indicate with picture along with your text in the question and in the exam. Along with that, advantages and disadvantages of both, advantage of vector and advantage of raster. What are the disadvantages of vector and raster we have? That has to be read. This question will come, friends. A representation of this that special data models, and then advantage and disadvantage. Vector, raster, you have to read carefully, which is 90% I say important. Well, few disadvantages also we have in this vector format, like data structure is complex to build, and analyses are hard to perform. As I said, for analysis purpose, or you want to give some weightages to analyze, you have to convert this vector into raster format, which is not feasible in this vector. That is then the disadvantages. Needs higher end software for complex analysis. A simple analysis like our many open source were there, but all analysis cannot be done. Like hydrology model, if you compare, it's not possible. In this, you have to do vector analysis in this particular commercial version, right? So likewise, that high-end software is required for complex analysis to perform a vector data model. And needs costly software and hardware for vector analysis, as I said just now. And point line polygon layers can be overlaid in a single coordinate system, where you cannot perform if point is some other coordinate system, line is another coordinate system, you cannot perform together, you cannot overlay one upon another. So the data's point, line, polygon must be, all three layers must be, special interest must be in single coordinate system only, then only you can overlay or we can perform. So the same geographical area, different coordinate system, it will not allow another disadvantage. So it must be in same or single coordinate system. Well, the spatial data comparison between vector and raster data structures. That is advantage and disadvantage we discussed. If you compare data structures, vector and raster, starting from input to output, how it performs. If you go the parameter, first one is input. Input of the vector data is mainly digitization or vector conversion of scanned outputs. Mainly we will not even use vector conversion. Very rarely we use vector conversion, but in the vector format, if you want to input the data into your system, data has to be digitized. Manually, we used to digitize all the features from the raster. Otherwise, you cannot input your data. The manual digitization will take much time as well. But it's very accurate and very clarity of information. You can describe features very clearly in the vector format. Whereas raster data can be input. How we will input the raster is amenable to scanning or raster conversion of digitized outputs. Basically, we do scanning to input our raster data. If you have the printed topo sheet or cadastral map, that has to be scanned it. That has to be scanned it, and we will input after scanning as a raster data, which will come as a JPG or PDF, the TIFF format. That both will, the TIFF or JPG will be used into as a raster model. The precision is accurate and more precise vector that limited to grid size, that is the raster. And redundancy is very less in vector. Redundancy is more in raster format. And attributes, direct linkage to DBMS, which stores attribute data. Cell value represents attribute. Here in raster, only cell value represents attribute, whereas in vector, direct linkage to DBMS. Even friends, after digitization, after you have the limited attributes in the vector format, if you have some other data, that data, if you have an Excel, that directly can be linked to your DBMS, database management systems, or your data directly in vector format. So attributes can be joined easily in vector. You cannot do in raster, where you have only cell representation in the raster. And the remote sensing interface need to convert the image to vector. When you come to the remote sensing interface, and in vector, it has to be converted in a vector format, data structure, it has to be converted from the remote sensing. How you convert? You have to manual digitize. Just a minute, somebody asking something. Okay. Who friends you are hearing? Hello? Can anyone respond? Respond, please.
Yes, sir. Yes, sir.
Yes, sir.
Thank you. Yeah. Thank you. Yes. Thank you. Well, then if you come to the raster one, the spatial analysis, direct analysis of image is possible, because that remote sensing interface, remote sensing data itself, it will be raster based analysis software, and then the data of remote sensing comes in raster format, made up with the picture element, right? So it's easy in raster, but when you come to the vector, the remote sensing interface has to be converted, the image to vector using point, line, polygon. The data has to be digitized or converted from raster to vector, then we can use. And the spatial analysis is complexity is higher in vector. You can do a number of spatial analysis, and complexity analysis is very higher here in vector. And whereas raster is amenable to map, algebra, and easy to analyze. Simulations complex and difficult here, but simulations specifically in the raster is possible. In the vector it is difficult, but in the raster simulations is very easily you can do it. It's possible over there. And the output is in vector is very high quality because you will digitize or extract from all the rasters or features very clearly using the cartographic quality on plotters. And you will get the print direct, you will get the print and you will give the design or desired color pattern, etc. So output will be very high quality, in fact, in the vector. Whereas in the raster, you cannot change anything, friends. So mainly this data and the printers will be used directly. You can get the print. So this will not be much higher quality, you can say, than if you compare with the vector. So output is somewhat very high clarity quality you will get when you use in vector. So these are the few comparison between vector and raster data structures, friends. Starting from input, how it is, which is feasible, how it can be done, precision, how it be, redundancy, attribute, remote sensing interface, and spatial analysis, and simulation, and outputs. Then come to the data conversion. Yes, just now we talked. Data has to be converted or transformed or changed from vector to raster or raster to vector. So this too is required in GIS, friends. Some cases we have to convert from vector to raster also. Sometimes we have to convert from raster to vector. As I said, when we go to hydrology model for watersheds projects, so always we have to convert from vector to raster. Then only you can perform that analysis, hydrology model, you can give the weightages, right? So how it can be conversion based on the needs of the GIS project, as I said, the conversion will be taken up. If the selected GIS is a vector GIS, then for analysis, all layers should be in vector data model, right? When analysis, all the analysis based on the vector based, the particular project, then the data has to be converted in vector data model only. The raster to vector conversion provides a generalized output as it converts pixels to lines of polygon. Pixels to lines of polygons, which may not be as accurate as digitized output. Yeah, sometimes you can convert your data directly from raster to vector, but when you convert directly raster to vector without any digitization, it will all pixels will be converted as a polygons. But it's not accurate as digitized output when we use the point line polygon to digitize, but you cannot expect that much accuracy. So the another model to convert directly, you can convert from raster to vector. There are tools available in the GIS. Okay, and to make it accurate, high resolution raster data model can be used for conversion. Therefore, the conversion of raster to vector model has to be carried out only when it is absolutely necessary. Otherwise, always we used to try from raster to vector only. We do digitize from raster to vector. Data will be converted, basically 90% data will be converted from transformed from raster to vector in GIS, not vector to raster, but around 10% will be done, which is not much accurate as vector data, right? Keep in mind, friends, data can be converted both the ways, right? But always it's accurate when you convert from raster to vector using your raster-based analysis software, GIS softwares using point line polygon. Okay. This is the data conversion figure which you have in your book. The various types of data and formats. And we have maps, we have images, we have GPS data, we have descriptive text, we have tabular data. This is various data and formats, right? Maps, images, GPS, descriptive text, tabular data. So these all will be made up with the geo database. Then from this geo database, analysis will be done. That spatial analysis will be done. So in that, data will be converted. Please kindly see. Maps, image, GPS, descriptive. GPS data will be by default it will stored as .gpx file format. Images will be .img. Maps will be TIFF, JPG, PDF, etc. Right? This all has to be converted. This all has to be converted. Like descriptive data, a tabular data. These two also tabular data we have to convert into Excel, or Excel has to convert into CSV file to add directly to create or to add your geodatabase, common delimited text CSV file, right? Or it has to come some database file format, right? So these all data has to be converted. Again, directly GPX we will not use. In GIS environment, you have to convert those GPX data. That is, GPS will come under .gpx. File format is .gpx. That data has to be converted again shapefile or KML file, right? Likewise, all these data will be converted. Which you are seeing the 5 types of data types and formats, map, image, GPX, descriptive and tabular data has to be converted and to create a geo database. After that, the geo database has to be converted as a spatial analysis. After geodatabase, you have to convert again spatial analysis. The analysis also has to be converted into map format or maps. This is the conversion, data conversion in GIS environment. And second unit is non-spatial, or another word is attribute data models. Friends, as of now, we discussed only spatial data, right? A spatial data model. The second one is non-spatial data models. The non-spatial or attribute data sets are relevant only for vector model. As I said, its attributes you cannot add, you cannot join. The raster will not have any attributes over there except pixel, the pixel number or DN value, right? So non-spatial data sets are relevant only for vector model based spatial data sets, because in raster spatial data, the attributes are stored as a separate data layer. Non-spatial data has got a set of attributes. Non-spatial data got a set of attributes which describe the characteristics of spatial data. As already I described, if you have the road or water body or village, you can show as a village boundary. The village, about that village, you have to write that we call non-spatial. Spatial means which you will draw, which you will see with your naked eye, which is located on the surface of the earth, which will have the latitude, longitude, that we call spatial. About that particular spatial feature, as I said, in case of village, suppose village will be drawn as a boundary. So for village boundary will be spatial, right? Spatial data. To that, name of the village is attribute. Total population of the village will be attribute. Population density, sex ratio, literacy rate of the village, right? All these called attributes of those village, of that village, right? This we call attribute, characteristics of that spatial data. It describes characteristic of spatial data. As I said, road is spatial data which will be drawn using linear entity. And about that road, when you write about name of the road, type of the road, condition of the road, right? Then under which scheme it was constructed, right? Total length, weight, quality, who is maintaining, right? All these called characteristics of the spatial data, which called non-spatial or attributes. The spatial data and its respective attribute data has to be stored, retrieved, and analyzed for deriving useful information in map form or table form for the use of decision makers. These two are very much important, friends. Alone spatial data will not do for the decision makers of planners. What is that? If you see in the map, suppose there's a point shown as NIRD in the map, right? Or polygon shown as NIRD. But after seeing that, I doesn't know that, I cannot plan anything only seeing that spatial entity or spatial data. Because if it is NIRD name, I know, but what purpose that is? How many faculty were there? What are the activities NIRD do, right? And when it was established, what type of centers we have in that NIRD? Okay, all this has to be there to take decisions. For decision making, you must have attribute data along with your spatial data. As I said, simple road is there, will not do. Road तो है, हम देख लिए road as a geographical entity or drawing, पक्का road ठीक है, but कौन बनाया, किसने बनाया, कब बनाया? Whether can we again plan for the modification of the road, or there is a road, Kacha road, is it applicable for the Pakka road under PMGSY scheme? So you have to see those attributes. Without that information or attributes described, you cannot plan, friends. So you should know it, whether the road is applicable for PMGSY, like where it is connecting, to which hamlet it is connecting, which village it is connecting, what is the population of the village. If it is more than 500 population, yes, it is the particular, the road is connecting to the specific village, which is having more than 500 population, but still it is Kacha road. That road can be taken up under PMGSY scheme. For that purpose, you should know what are the attributes we have in that road. Alone seeing the road will not help to plan. Decision makers cannot take any decision. Not only road, not only these particular buildings, all spatial entity, spatial geographic information system. Friends, keep in mind our GIS is not only geographical system. It's a geographical information system where decision makers can take decision after seeing your spatial data along with your attribute data, right? Otherwise, there is no meaning. Without attributes, if you see some spatial data, there is no meaning. Yes, we see satellite imagery. Simply, we see the satellite image. We don't know what is what because there is no attribute on the satellite image. Village you can see, houses you can see, but the village name you don't know on the satellite image. So what is the use? Isn't it? The forest is some vegetation showing. Whether the vegetation is crop or forest or horticulture crop, we don't know. So attributes or non-spatial data is very much important for the decision making or for planning of any kind of projects or programs or schemes in rural development or any other sector as well. So friends, GIS is geographic information system that both the data, spatial and attribute, both are eyes of the man, right? दोनों अंक चाहिए. कौन सा अच्छा है? स्पेशल डेटा अच्छा है, नॉन स्पेशल डेटा अच्छा है, और व्हिच इज इंपॉर्टेंट वी कैन नॉट से. बोथ आर सेम. दोनों अंक एक ही है आदमी को. तो दोनों डेटा जरूरत है. विदाउट any single data, you cannot take any kind of decisions or you cannot plan further for any kind of projects. So this attribute data requires a database model which enables the users to carry out spatial analysis by joining spatial data with non-spatial data. There are number of data models available for storing non-spatial data. So I think you might have read even for storing your non-spatial data also, there are a number of models are available. So let us see what are the models we have. This is a database management system, but DBMs are there. DBMS is a computer program to control the storage, retrieval and modification of data in a database. The primary goal of DBMS is to allow for definition of data, their attributes and relationships, as well as providing security and as an interface between the end users and their applications and the data itself. So it comprises software tools for structuring, relating and querying data and designing of data entry and report forms. So friends, keep in mind the DBMS is database management storage system. This is a data storage system. Basically, DBMS plays a pivotal role in the GIS because they liberate the GIS software designers from building and maintaining a sustainable and complex part of a large database system. So DBMS is very much essential. So you can store data in different model. Okay. And how it can be stored is the conceptual data model we have, logical data model we have, physical data model we have. So what is the conceptual data model? So in data modeling terminology, basically the different views of the same geographical area obtained by an engineer or a geographer are called conceptual model. Logical data model is different, then conceptual is different. The different views of the same geographical area obtained by engineer and geographer called conceptual data model, whereas logical data model is the text level of data abstraction is called logical data model. The next level of data abstraction. A logical data model describes the data in as much as detail possible. It will give more details in logical data model, right? So hierarchical data model again in logical data model. Hello. Yes. Hello. Rituraj. Yeah, Mr. Rituraj, kindly keep it mute. Hope you are all hearing. Hello.
Yes, sir.
Somebody is unmuted, so his noise is coming. Please kindly keep in mute. Friends, is it boring? Okay. Yeah, I can see. Yeah, I can see. I'm trying my best, right? Please keep in mute, friends. Please keep in mute. Right. I'll go ahead. Okay. Okay. Thank you. Thank you. Thank you. So the physical data model in physical data modeling, which represents the computer implementation oriented view of the databases, is the third level of data abstraction. So there are conceptual data model, logical data model, and physical data model. These two will be used. And the mode is physical data model is very much important. It's a computer implementation oriented view of the database, which we use in GIS, in fact. Then RDBMS, this what you might have heard, friends, Relational Database Management System. Its Relational Database Management System will be used in GIS. You might have seen in the picture, there are boundaries, administrative boundaries, maybe district boundaries, you presume. If you click on any one of the district, about the district, the attribute table will be shown exactly. What is that? The ID, length, population, the name, right? The sex ratio, right? To the specific data, you have the relation link. So it is called Relational Database Management System. So based on relational model, it is a collection of organized set of tables from which data can be managed easily. Data structures like fields, records, files, and objects are optimized to deal with very large amount of data stored on a permanent data storage device. In relational database terminology, like you see the table which is showing, I think if you see the GIS map, same it will indicate like this only, friends. The map will be there as a geographical feature with your boundary features. If you click on any one of the boundary, if you simply click, the related information will be shown as a separate table that we call attribute table in GIS terminology. So that will indicate your non-spatial data, right? So this relation, it will be linked together with spatial and non-spatial. This is also important, friends. Many times the 2 marks question has to come. What is the RDBMS? Relational Database Management System. Please go through this Relational Database Management System. This is also very much important. Okay. So sources of attribute data. Of course, we have different sources for spatial data. Will be discussed in, I think, next coming slides. And what are the sources of attribute data? Where it comes, these attributes? As I said, road is suppose there, where it will come, the road information, right? Like road name, how I know, or connectivity hamlets, how I know, right? And what is the length, what is the weight, when it was constructed, under a scheme, under which scheme it was constructed. These are all where I can get, friends. To get this attribute data, there are a number of sources we have, like government reports, records we have, National Informatics Centers, NIC websites we have, where we have the MIS systems, Management Information Systems. From that you can get, which is developed, maintained by the NIC. And Census of India, you can get all census related data. This is another source of attribute, the Census of India. And the statistical yearbook, which will be given every year, statistical yearbook, that's another source. At village level, all the data will be published. Each and every district handbook will be there. In that, all data will be published, which can be used as a source of attribute data in GIS environment, statistical yearbook. And India Stat, India Water Portal, IWRS, likewise, number of portals we have, friends. If you take NREGA scheme, we have NREGA Soft, where you can see all MIS data at village level, number of job cards, number of assets, physical achievement, physical target, financial achievement, financial target, right? A number of job cards in that village. These all attributes can be get from NREGA Soft. Similarly, all schemes, all programs, we have MIS systems, Management Information Systems. From those systems, you can get the attribute data directly. And the PMGSP also, we have the MIS system. PMAY scheme, we have the MIS system, that is IOI, that is our soft, right? The number of houses were sanctioned each and every village, right? All these data can be taken from different sources. And also another source which I have not mentioned, friends, this attribute data can be collected through field survey also. Yes, you are seeing the road, but you can go to the field and collect the basic information you can get from the signboard of that particular asset which was created under different various RD program. And rest data can be collected, the implementing agency, which I was not mentioned over there. Implementing agency you can collect, the person you can collect, even from beneficiaries you can collect directly. Data can be collected from the beneficiaries also. Directly go and meet with the villagers, you can collect the data, when the road was constructed, who has maintained, how much money they spend if they know, or other physical parameters they can able to address to you. Along with these other secondary sources. So these are the sources of attributes, friends, which can be used in our GIS database creation. Well, the third unit is spatial digital formats, which is not, I don't think it's very, very important, but you should know what are the spatial digital formats we have. And you're all aware that computer works well with the digital data only, isn't it? If you have any paper file, if you wish to use, that has to be scanned, that has to be converted into digital format. So then only a computer works directly, otherwise computer will not work. Hence, the maps have to be converted into digital formats. The maps have to be converted into digital formats. So basically now our data, many data are coming in digital form, but earlier we used to get like topo sheets and all in printed form from the Survey of India. Then we used to scan it, and for converting into digital form, then we will be using in the GIS environment. But now you can get directly digital form. Even you can freely download also. Survey of India topo sheets can be downloaded using your Aadhaar identification as authentication of your personal authentication. That can be downloaded digital data directly, and the latest topo sheets also they kept in that. And the spatial data content in hard copy maps have to be stored in software compatible digital format. As I said, suppose if you use GIS, the data should be, if it is just scanned on IMG format or TIFF format has to be, we used to do, and it will allow GIS this both raster format. In case of vector, it has to be in shapefile, basically, .shp shapefile format. If we use that the same spatial digital format, if we use AutoCAD software, the data has to be converted into digital format using .dwg file, that is drawing file. So these are all some of the digital formats which will be used for converting of spatial data. And spatial data sets are created in different digital formats by various software vendors. Some of the file formats are priority formats, while some formats are created for use in another software. Like GIS also, you have the converting option software itself. You can convert shapefile to AutoCAD file, that is DWG file. You can convert shapefile to KML file. You can convert to PDF. You can convert to JPG. There are conversion options that digital format can be changed one to other, and different softwares will have different own formats, and they're also having to convert other formats as well in their own software. Well, few these digital file formats of spatial data given, friends, you can see like picture. Picture basically comes in 4 digital formats, that is GIF, BMP, PCX, and TIFF. So these are the 4 picture data formats. And come to the satellite image, which is essential for us to use in GIS, which is very much essential. In fact, we do basically use the satellite data imageries that will be stored in BIP, BSQ, BIL, DEF. These full forms also given what exactly in your textbook. Please go through your textbook. What is this BIP, BSQ, BIL, DEM, etc., which is very much essential. And come to the vector data, it's in Tiger, DLG, DOG, DWG, DXF, map, tabbed, dot, DGN, ARC export, coverage, shapefile, that is SHP, SSX, DBF, database file, IFSC, KML, etc. These are all vector data file formats. And towards right side, you can see the priority or proprietor, like ISRI is a proprietor of this SHP file, coverage file, as well as IFSC. Whereas KML is proprietor is Google. Google, its own file format is KML. Like AutoCAD is having DXF and DWG. Right, and then the final data type is grid data, that is DEM and SDTS. That USGS data might have heard, they are using DEM and SDTS format. And the DTED is there, the National Geospatial Intelligence Agency, which will have their source of data is DTED. And USG is another format we have, that is GTOP O30. So these are the grid format, in fact, all last three. And we have 4 types of data: picture, satellite imagery, vector, and then grid data. And the digital file formats being given, and proprietor of those files or data files, file formats have been given towards right side. Please go through it. This is not much important according to my knowledge, friends, data digital file formats, but still use vector. What are the vector formats we have? What are the raster formats we have? Particularly satellite image and other. Keep in mind that what are the formats we have. And as I said, sources of attribute we have seen, and this slide indicating sources of spatial data where we can get the spatial data. You know what is spatial data already? And these are the 7 sources I mentioned, friends, which we use as a spatial data. And the first one is National Remote Sensing Center, NRSC, which is under ISRO, Indian Space Research Organization. And you can get the data from this NRSC in 4 ways. The one is Indian and foreign satellite data can be obtained, can be taken from the NRSC. Indian satellite data you can get, as well as foreign data also can be, satellite data can also procured from NRSC, which is located in Hyderabad, but through website you can browse the data availability, accordingly you can order. And the second one is Bhuvan Data Services, again, which is under NRSC only. They have initiated, Bhuvan has initiated number of projects, right? Number of data services, Bhuvan. Even free raster data also can be, Bhuvan raster data is the 4th one, like satellite imagery also can be downloaded, archive data can be downloaded. NRSC has also initiated that OpenEO, Earth Observation Data Archive, it can be downloaded. And the data services like some vector data also available now under Bhuvan, right? So these are all data can be taken from NRSC. That is the source of spatial data as one. The second one is Survey of India. The Survey of India also another important source of spatial data, like topographical maps, like toposets, etc., can be taken from SYI. Open series maps, defense series maps, general wall maps, and maps for educational use. Friends, if you go through your particular book, there are number of map formats being given, and all these data can be downloaded or taken from you can procure from the Survey of India. And another source is Geological Survey of India, GSI we call. From them you can get geology map, geomorphology, tectonics, etc. All these maps in different scales, they are already generated and you can obtain from the GSI. The 4 sources, National Atlas and Thematic Mapping Organization, NATMO. You can get from them, from the NATMO also. There's another source to get the data. And the Census of India, yes, they have, even Census of India are having GS spatial data also. They show different census information in the map format, like population density, sex ratio, district-wise, state-wise, country-wise, right? And national NIC also another source. You can get the spatial data from NIC also. They also develop different spatial data. They are generating different spatial data. And then 7th one is cadastral map, which will give the land ownership. The cadastral map will give the land ownership, particularly to collect the revenue. They introduce these cadastral maps. This is another source. These are the 7 sources I mentioned over there, friends, for spatial data, which you can obtain from these sources. And these are all sources were mentioned in our book. Please go through it. If you wish the different scales and etc., the brief about this, you can go through, or this presentation will be given to you. You can keep in mind, please. They may ask the question like source of spatial data and source of non-spatial data, right? So you have to mention all this. You need to go describe, but sometimes they may ask what is the cadastral map, what is the geology map, what is the geomorphology, right? What is the topographical map? Then you have to describe. What is the Bhuvan? Please go through the Bhuvan, friends. The last, I think, 3 years, they're asking about the Bhuvan. About the Bhuvan, right? What are the data sets available in the Bhuvan? What is the purpose of the Bhuvan? What are the projects they have in the Bhuvan, right? Please go through it. It is the last unit, friends, that is spatial data creation. So we have seen data, the data model, data types, entities, right? And then we came here, spatial data creation, how spatial data can be created. It can be collected from various sources, such as spatial data can be connected from different sources. Just now we mentioned over there, like topo sheets, aerial photographs, which will give the jet value along with your spatial information, and satellite imageries, and cadastral maps, which will give land ownership, census and field survey. This data also can be used for spatial data creation. Field survey, census and field survey data can be used. GPS surveying data can be used, and also total station survey data can be used. So these are the spatial data sources, right, which can be created using these data. The spatial data can be created in GIS environment. So friends, you come before creating this, you have to create a database. I think everyone is aware what is data, what is database. Now we talk about geodatabase, right? The data means, I think you're all aware what is data, raw facts and figures called data. The data means an organized collection of data. An organized collection of data called database. So in this database, we added geodatabase. When you work with the geography, then it become geodatabase. A geodatabase is a storehouse of geographic datasets of different files. This database can be a MS Access database, RDBMS, SQL, PostgreSQL, XYZ. There are a number of database JS is using. It can hold feature classes, raster datasets, tables, XYZ. But in ArcGIS, but unfortunately, we're not going to use the ArcGIS, the commercial version, because later on for practice purpose, you should have the software, which is not possible to you to buy that software. That's why we are introducing open source software that probably QuantumJS will be teaching to you, and other raster analysis open source software will be thought of, right? But in ArcGIS, ArcSDA geodatabase is there, file geodatabase is there, the personal geodatabase is there. Earlier, we used to do even this geodatabase creation. But in open source QuantumJS software, you no need to create this ArcSD or file or personal geodatabase. Directly, you can create the feature classes as a shapefile. As a shapefile or layer, directly this data will be stored in QuantumJS or open source JS software. But earlier in the commercial version, that is ArcGIS, different geodatabases they used to do. That is ArcSDE. It's a collection of tables stored in relational database and termed as enterprise geodatabase. It will have a large number of data, and anybody can work from anywhere when you use ArcSDE, right? And then file geodatabase. The geodata sets can be stored in file geodatabase and can store up to 1 TB. The file geodatabase storage capacity is up to 1 TB. And personal geodatabase, it stores the data sets in MS Access data file. Its storage capacity is 2 GB only. The maximum 2 GB can store your data, special data, as a personal geodatabase. After this, what we do is either one of the geodatabase we used to create in ArcGIS, it has to be created. And after that, you have to create feature data set within that personal geodatabase or file geodatabase. The feature data set again consists of content of various feature classes or layers or shapefills, is another word, right? The various feature classes, a common projection system, it will bring into feature data set. And the last one is feature class, which we call now as a shapefile or layer in Quantum. It will be created as a point, line, or polygon entity stored in feature classes in ArcGIS. Friends, in our QuantumJS, we create directly this feature class. We'll not use word as a feature class there. We do use a word as a layer that will stored as a shape file in open source JS software. We will not use any kind of database over there. Directly we store as the last option here as a feature class. But if you use ArcGIS, you have to create any one of the database, either file, ArcSD, or personal. After this geodatabase, you have to create a feature dataset within that geodatabase. Within that feature dataset, you have to create all these feature classes to create your complete geodatabase. Friends, to create these spatial datasets, you have different options. Like first one is keyboard entry, and then scanning, and manual digitizing, automatic digitizing, automatic line follower, or electronic data transfer. These are the different options where you can create your special data sets. Keyboard entry or scanning, manual digitizing, which we do basically manual digitization only to enter to create your database, manual digitization only, right? The automatic line follower. There are a number of options, but we do use maximum 99% we use manual digitization to enter to create our special data using point, line, polygon, convert from raster to vector to create our database in GIS environment. Friends, sources of errors and corrections. Well, once you generate the data, there will be number of errors occurs during your creation of your spatial data. Errors in GIS can occur due to various reasons, friends. These errors are avoidable or can be reduced if the data encoding was done properly. How it can be? Errors can occur both spatial and attribute, both the data, दोनों डेटा में आपको मिलेगा errors, स्पेशल डेटा में भी हो सकता है और एट्रिब्यूट डेटा में भी हो सकता है. तो major sources of error occur during data input, data processing and data display. ये तीनों जगह में होता है आपको errors. The major sources of errors occur during data input, data processing and data display. Some of the source data error in raster data are cloud cover, particularly raster data, satellite imagery, etc. When we take it, the data error possibility is in cloud cover, scan line error. When it's scanned, the line error will be there, then shadow, etc. in raster, particularly raster data. It comes to the vector data, errors in vector are undershoot, overshoot, spike, pseudonode, duplicate entity, unclosed polygon, knot and silver polygons, etc. Friends, the silver duplicate polygon will be created, sometimes undershoot, because as I said, once you create the data, road is there, the main road is there, the connectivity road is there. When you digitize, we will not put the vertices directly on that road. Sometimes it's close to that. So there will be a gap. It will be called undershoot. Sometimes we cross that road. The vertex last vertex, when we keep it, it will cross over the main road. It's called as overshoot, right? So likewise, there are a number of errors will be there in vector data, which will be removed. All these errors can be removed using topology built. Hello? Hello? Can anyone?
Hello, sir. Hello.
Yes,
Yeah.
sir.
Okay, it's 11:30. My presentation is over. Now the session is open for discussion, friends. You can text me. Okay.
Sir,